Okay, let's talk about nonlinear regression. So it's very similar, at least on the TID4 calculator, to what we did for linear regression quite recently. So let's go to stat, right arrow. And before, what we did was we chose option number 4 for straight line regression. Find the straight line that best matches up with the points. But we've got all these other choices down here. We could find the logarithm that best matches, or the quartic polynomial, or cubic, or quadratic, or whatever. And we don't really need to go through everything, but let's just go through quadratic and cubic. So if I select quadratic, then it looks just like the linear regression. But of course, first I'm going to need to go to stat enter and put in some data. And I'm going to put in some new data. Let's see, did I hit the clear button? I guess not. Okay. Okay, and I've got some data. How cool is that? So I'll go to stat, right 5 for quadratic regression. So a quadratic function is one where the highest power of x is 2, and the graph is a parabola. It kind of goes like that, or starts low and then comes up and goes back down. And we'll see an example of that in a moment. Just like with linear regression, I can tell the calculator, hey, let's do alpha trace and store the function it's about to give me, store that in the y equals menu. If you're on TI-83, you won't see this screen. Instead of doing the alpha trace, you'll just do vars, right arrow, and then enter, 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 3 enters. Vars, right, enter, enter, enter. So on a TI-83, you could do that on this too, but it really wouldn't be necessary. Okay. Well, the r squared is definitely closer to 0 than 1. So I just made up those points. I didn't know if they'd be a good fit, or if a parabola would be a good fit. Quadratic function would be a good fit for them. Apparently, it's not a good fit. So, but there's the function, y equals 0.11 x squared minus 0.84 x plus 4.71, if I round it off to 2 decimal places. Because I did the alpha trace thing, if I go to y equals, there's the function. I've got plot 1 turned on already, so I can go straight to zoom 9. And as you can see, yeah, this data doesn't really fit a parabolic pattern. So that's why we got such a low r squared value, so close to 0, suggesting, yeah, this is the parabola that best matches the data, but it doesn't match it very well at all. So anyway, that would be how you would find the parabola or quadratic function of best fit. So it doesn't just have to be a straight line. What if we were to try this same one with a cubic? We'll just keep that same data and go stat right. And then let's pick option 6 for cubic regression. And let's go alpha trace. And then you know what? I'm going to pick option Y2. And I can see both of them. Okay. So I hit enter, and the r squared value is still quite low, definitely better than the other, but very low. And the equation, the cubic function that best fits the data we entered, it would be y equals a, which is 0.07 x cubed. I'm rounding off the 2 decimal places again, plus b, which would be negative 0.88 x squared, plus 3.26 x, plus 0.71. Okay, if we take a look at the graph, okay, the skinnier line, I think it's red. I don't know, I'm colorblind. It fits it better. It kind of looks like it follows the pattern a little better. It's not great. And you know what? You could go back to stat right and maybe try quartic or linreg or lnreg or something. See if you find something better. Anyway, that is how nonlinear regression is done. It's basically just like the way you do the linear. And that's it.